I welcome you for this presentation. In this presentation, we are going to discuss about secure hash algorithm SHA. It is a very famous algorithm. So this is the overview of this presentation, that is introduction to the SHA, that is secure hash algorithm, and how this SHA was introduced, then the revised secure hash standard, then SHA-512 overview, then SHA-512 compression function, then SHA-512 round function, then the latest SHA version, that is SHA-3, and summary of this presentation. Generally, this SHA, that is Secure Hash Algorithm, was originally designed by the National Institute of Standards and Technology and the National Standards Authority in 1993. Actually, this SHA, that is whatever the SHA they originally designed in 1993, has the version, that is that SHA is named as SHA-0. That is SHA-0, that is the basic structure of the SHA. That is this whatever designed in SHA-93 is SHA-0. Then there are some disadvantages in this SHA-0. Generally, we know what is the functionality of the hash function. That is, we are giving the variable input size and applying that variable input size, and we are getting a fixed size value. That is the hash function. The input to the hash function is the variable size, but the output of the hash function is a fixed size. So there are some drawbacks in the basic structure of the SHA, and it was earlier named as secure hash standard and not secure hash algorithm. Later only it was named as secure hash algorithm. Then the SHA-0, that is the basic SHA, was revised in 1995 and it was named as SHA-1. Then the US standard for use with the DSA signature scheme, the SHA-1 was used with the signature DSA, Digital Standards Algorithm Signature Scheme, Digital Signature Algorithm Signature Scheme, and this was given in the standards in FIPS 1801 1995. Also, it was recorded and has a standard, that is Internet RFC 3174. So SHA is in RFC 3174, and the algorithm is called as secure hash algorithm, and the standard is called as secure hash standard now also. So based on this, SHA is based on MD4 with some differences. So MD4 as well as, that is message digest. MD4 means message digest 4. Now we are having the MD5, that is message digest 5. So this SHA as well as this MD4 or 5 is also a hash algorithm only. These two are very famous hash algorithms. So this SHA is based on this MD4 with some differences, and the SHA produces a 160-bit hash values. And in the 2005, the results on security of SHA-1 is raised to some concern, and it's used in some future applications as well. So they designed, that is, they also revised SHA-1 to SHA-2, and in SHA-2 there are 3 variants. Let us see that. So NIST issued a revision in FIPS 180-2, that is earlier it is 180-1, now it is 180-2 in 2002. So this FIPS 180-2 adds 3 additional versions of SHA, that is SHA-256, then SHA-384, then SHA-512, and these 3 are called as SHA-2. Now SHA-2 means the SHA-2 comprises of the SHA-256, SHA-384 and SHA-512. So in this presentation we are going to discuss about SHA-512. It is a very famous and mostly used secure hash algorithm. And this SHA is designed for compatibility with increased security provided by the AES, that is Advanced Encryption Standard Cipher, and the SHA-2 structure is similar to that of SHA-1. So the base is SHA-0, that is the general structure. So the users of this SHA-0 find some difficulty or some disadvantages in SHA-0. So the NIST planned to revise SHA-0 and it was named as SHA-1. Later on in 2002, they faced some difficulty or they found that some disadvantages in SHA-1, and in order to overcome that, NIST decided to revise SHA-1 and they come out with SHA-2. And this SHA-2 has three versions, that is SHA-256, SHA-384 and SHA-512. So this structure, the base structure of SHA is same only. Some delta increment is there from SHA-1, SHA-2, then SHA-3 in order to provide more security or increase the level of security, and mainly this is for authentication data purpose only. Hash algorithm is for data integrity purpose. So in order to provide more data integrity, they are revising the existing SHA, and now they revised SHA-2 and now SHA-3 is in use. So each and every levels are providing better security levels rather than higher. So we are having better, in order to have better security levels, NIST is frequently revising the SHA-1. So this is the overview of SHA-512. This is one of the versions in the SHA-2. So SHA-512 consists of 5 steps. 5 steps, first 2 steps are very simple. Then from third steps onwards only it is somewhat complex. So here we know that for any hash function we have to give an input of any variable size. So any size we can give, but it will produce a fixed size message digest or hash value only. So here we are having, let us see this diagram. This is the block schematic of the SHA-512, overall block schematic. Here you see the message is there. After the message, in the basic diagram in the last presentation we have seen that here after message we have P or L. What is P? P is a padding and L is the length of the message. Because here we are performing some padding. So we need to know what is the size of the exact message. Because with respect to padding, anyway we are fixing the size. But what is the exact size of the message, that we need to know. So for that only we are having the L. So how we are performing padding? Always the first digit is, first bit is 1 and the remaining bits are 0 for the padding. So the message size is of L bits, but we are having N into 1024 bits. So always the message size we are dividing it into 1024 bit blocks. Okay, so in order to make it as a multiple of 1024 only, we are performing here padding, and the length field is of 128 bits. So the first step is append padding bits. We are having a message. From that message we need to generate a hash value. So first step is we need to append padding bits. So next step is we have to append the length. After padding the bits we have to append the length. Then we have to check that it is of size N into 1024. Then what we are doing is we are splitting the message into 1024 bits of N. We are generating N sub messages from the message. That is, we are splitting it into N blocks of size 1024 bits each. Then we are initializing the buffer. Totally here we are having 8 buffers, that is A, B, C, D up to H, and they are represented using some hexadecimal numbers. So 8 registers are there. Initially we have to initialize the register to 0, then only we have to update. And in the fourth step what we are doing is we are processing the message in 1024 bits, that is 128 word, 120 blocks, which forms the heart of the algorithm. This processing only forms the heart of the algorithm, because here only we are performing computation and we are generating the hash value. So finally in the step 5 what we are doing is we are outputting the final state value as the resulting hash. So generally we are having H naught equal to IV. IV is the initialization vector. So what is H naught equal to IV? We are having 8 registers. That initial registers only we are calling it as initial vectors. Then we are finding the HI value equal to modulo 64 sum of addition modulo 64 of previous hash value comma all the registers, that is the last register value. Then MD, message digest, is equal to last hash code, we are calling it as MD, message digest. So see here in this diagram we are having a compression function F here, then we are performing modulo addition, then we are getting the hash value. So the general final output is of size 512 bits. So here we are performing addition modulo of 2 power 64. This plus means addition modulo of 2 power 64. Here only we are representing it as a equation form. This last step only we are representing here as a in equation form. So this is the general architecture of SHA 512. So totally it consists of 5 steps. Let us see the complicated steps. So here I already told you this compression function or the function round function is the heart of this SHA algorithm, and it processes the messages in 1024 bit blocks because we have divided the messages into 1024 bits. So each sub message is of size 1024 bits. And here we are having 80 rounds. That is the main thing, 80 rounds. So we are updating the 512 bit buffer using a 64-bit value, that is W2 derived from the current message block, and we are performing a round constant based on the cube root of first 80 prime numbers. So here you see this is the operation of the round function. I already told you that we are having 8 registers. So A, B, C, D, E, F, G and H. And here we are performing various operations, that is addition modulo. Then we are performing summation, some rotation operation we are performing. Then we are deriving the word. So many operations we are performing here. So here each 64-bit word is shuffled along one place, and in some cases we are manipulating using a series of simple logic functions, that is AND, NOT, OR, XOR, rotates, etc. in order to provide avalanche and the completeness properties of the hash function. What is avalanche effect? In the first unit you have already discussed about avalanche. That is a simple change in the ciphertext or plain text will change more bits, or in the key a small change in the key or the plain text will modify more bits in the ciphertext. So in order to provide avalanche effect only we are using these simple logical functions. More simple logical functions are used. So the elements used here are, see here, CH is a function. It is used to perform E and F, XOR not E and G. And maj is a function that is a majority maximum value we are finding, that is A comma B comma C equal to A and B XOR A and C XOR B and C. Then we are having the summation A. See here summation A is there. So rotation of A comma 28 XOR rotation of A comma 34 XOR rotation of A comma 39. Then here we are having summation E, that is rotation of E comma 14 XOR rotation E comma, that is rotate right. R means rotate right. Okay. E comma 18 XOR rotate right E comma 41. Then plus, many places we have seen plus, that is addition modulo 2 power 64. KT, we are having KT, it is a 64-bit additive constant, and WT a 64-bit word derived from the current 512-bit input block. So how we are computing the value for A, B, C, D means we are computing the value A equal to T1 plus T2. So how we are deriving T1? T1 equal to H plus CH of EFG plus summation 1 to 512 of E plus WT plus KT. Then T2 is summation 0 to 512 of A plus maj of A comma B comma C. Already we have discussed about these elements. Using these elements only we are computing T1 and T2. If you know T1 and T2 value, then we can find out the A value. A is equal to T1 plus T2. Then B equal to A. Just we are assigning, that is A value and B value are same. Then we are assigning C value, C equal to B. So A, B, C, 3 values are same only. Then D equal to C, D also C, then C equal to B, B equal to A equal to. So all these 4 values are same. Then E equal to D plus G1. Again we are adding this one, D plus G1. 2 times G1 is added. That is the meaning. Then F equal to E, G equal to F and H equal to G. Likewise, we are obtaining the value of all the registers. 8 registers value we are obtaining. Then we are finding out the value. So we have to perform 80 rounds. That is more important. 80 rounds we have to perform. So how we are getting the round function? So here we are having W0, W1 up to W79, 80 words we are getting. So how we are computing this means WT equal to sigma 1 512 WT minus 2 plus WT minus 7 plus sigma naught 512 WT minus 15 plus WT minus 16. So what is sigma naught and sigma 1? That is sigma naught of 512 of x equal to rotation right. That is we are just rotating right of x XOR rotating right of 8 XOR plus a shift right, rotation right and shift right of 7 x. Then sigma 1 of 512 how we are computing is rotate right of 19 of x XOR rotate right of 61 of x XOR shift right 6 of x. So this way we are performing all the operations and we are getting 80 words. So this is for one round. Actually this is for one round. We have to perform 80 rounds of computations we have to perform in this SHA-1 in order to provide the avalanche effect in the generated hash function. So that's all about the SHA-2, that is SHA-512. So now the latest version of SHA is SHA-3. That is SHA-1 is not a broken, but it is vulnerable to something. That is it is similar to how we are breaking this MD5 as well as SHA-0. So it is considered somewhat insecure. So only they go in for the SHA-2, that is especially SHA-512 seems more secure compared to other two, 356 and 384. Share same structure and mathematical operations as predecessors, so have concern. So NIST announced in 2007 a competition for SHA-3, that is the next generation NIST hash function. So in October 2012, the winner was selected and it makes as a SHA-3 is made as a standard in quarterly 2 in 2014. So some of the SHA-3 requirements include it replaces SHA-2 with SHA-3 in any use, so we can use the same hash sizes, and it also preserves the online nature of SHA-2. That is, we must process small blocks, that is 512 or 1024 bits, and the evaluation criteria for SHA-3 is it is security close to the theoretical maximum for the hash sizes, and it is providing better performance in terms of cost and time and memory. Then coming to the characteristics of SHA-3, it is more flexible and simplicity compared to the previous versions of SHA. So in this presentation, we have discussed about the introduction to the hash function, that is secure hash algorithm. Then the revised secure hash standard. Then we have discussed about the block schematic, the overall block schematic of SHA-512. Then how the compression function is working in this SHA-512. Then we have seen the round function. Then we have seen the latest version of SHA, that is SHA-3. Thank you.